In this video, we'll write the net ionic equation for H2SO4 plus NaOH. This is sulfuric acid and this is sodium hydroxide. We're going to assume that this reaction goes to completion and that all of this H2SO4, it dissociates into its ions. So we have our equation. The first thing we need to do is balance the molecular equation. This is the molecular equation, and it looks like I could put a 2 in front of the NaOH and then a 2 in front of the water, and this equation would be balanced. So we have our balanced molecular equation. Now we need to write the state for each substance. So sulfuric acid, that's a strong acid, and we're saying that that's going to dissociate into its ions. Sodium hydroxide, that's a strong base, that'll dissociate into its ions. And then we have a sulfate here. It's a sodium compound. Sodium compound's very soluble. That should also dissociate, so we'll be aqueous in water. That's a liquid. So these are the states for each substance. Now we can split the strong electrolytes into their ions. This will give us our complete ionic equation. So to do that, we need to know what the charge on these ions are. Hydrogen is in group 1 on the periodic table. It has a 1 plus ionic charge. The sulfate ion, SO4, that has a 2 minus. This is a good one to remember. So we have H plus, and this subscript here, that means we have 2 of those. And I'll write aqueous and liquids at the end. I won't write the states right now. Plus we have the sulfate ion, SO4, 2 minus. For the sodium hydroxide, sodium's in group 1. It has a plus charge. And the hydroxide, the OH, has a minus charge. So we have the Na plus for our sodium. And the coefficient right here means we have 2 of those. And then we have our hydroxide, OH minus. And the coefficient applies to everything. So we have 2 hydroxide ions. So these are the reactants. Now we can do the products. We said 1 plus, 2 minus, and liquids, solids, and gases, we don't split apart in net ionic equations. They stay together. So in the products, we have Na plus, and we have 2 of those. We have our sulfate, SO4, 2 minus, and then we'll have our 2 water molecules, H2O. So this is the complete ionic equation. Now we can cross out spectator ions. These are ions that are on both sides of the equation. In effect, they haven't changed. They're the same in the reactants and products, so we can ignore those. So if I'm looking here, I see in the reactants, I have this SO4, 2 minus, the sulfate ion. I also have it in the products. I can cross that out. I have 2 sodium ions, reactants, 2 products, cross them out. But everything else, that's unique. So that leaves us with our net ionic equation. We have 2 H plus ions, 2 OH minus, and that gives us, in the reaction, 2 water molecules. Let me clean this up a little bit and add the states in, then we'll have a nice looking net ionic equation for H2SO4 plus NaOH. So this is the net ionic equation for H2SO4 plus NaOH. We should do one more thing though. When we have the same coefficient in front, we'd like to reduce that. So we can reduce these down to 1 since they're all the same, and we don't really write the 1 in chemical equations. So this is probably a better net ionic equation for sulfuric acid plus sodium hydroxide. This is Dr. B, and thanks for watching.